Comparing the human brain to a computer's processing system. Introduction. The human brain and a computer's processing system are both complex information processing systems, but they differ in many fundamental ways. While both are capable of performing a wide range of cognitive tasks, the underlying mechanisms and architectures that drive these systems are quite distinct. In this article, we will delve into the similarities and differences between the human brain and a computer's processing system, exploring how they process information, store and retrieve data, and adapt to changing environments. The structure of the human brain. The human brain is a remarkably intricate organ, comprised of billions of interconnected neurons that work in harmony to perform a vast array of functions. These neurons are organized into distinct regions, each with specialized responsibilities, such as the cerebral cortex for higher-order cognitive processing, the limbic system for emotional regulation, and the cerebellum for coordinating movement and balance. The brain's structure is characterized by its plasticity, which allows it to continuously adapt and reorganize its connections in response to new experiences and environmental stimuli. This plasticity is fundamental to the brain's ability to learn, remember, and problem-solve throughout an individual's lifetime. The structure of a computer's processing system. In contrast, a computer's processing system is primarily composed of hardware components, such as the central processing unit, CPU, memory modules, and storage devices, all of which are interconnected by a complex network of electronic circuits. The CPU is the brain of the computer, responsible for executing instructions and performing calculations, while the memory and storage components are responsible for storing and retrieving data. Unlike the human brain, which is a biological system, a computer's processing system is a purely digital, electronic system. The components that make up a computer's processing system are designed and engineered to perform specific tasks efficiently, with little to no inherent flexibility or adaptability. Information processing. In the human brain. The human brain processes information in a fundamentally different way than a computer's processing system. The brain's neural networks use electrochemical signals to transmit and process information, with each neuron acting as a miniature information processing unit. The connections between neurons, known as synapses, can be strengthened or weakened based on the frequency and timing of the signals they receive, allowing the brain to learn and adapt over time. This process of learning and adaptation is known as neuroplasticity, and it is a key feature of the human brain that sets it apart from a computer's processing system. As the brain is exposed to new information and experiences, it can reorganize its neural pathways, forming new connections and strengthening or weakening existing ones. This allows the brain to continuously update its internal models of the world and improve its ability to solve problems and make decisions. Information processing. In a computer's processing system. In contrast, a computer's processing system operates on a fundamentally different principle. Instead of using electrochemical signals, computers use binary digits, bits, to represent and process information. The CPU executes a series of instructions, known as a program, which tells the computer how to manipulate and transform these bits of data. The processing power of a computer is largely determined by the speed and efficiency of its CPU, as well as the amount of memory and storage available to it. However, unlike the human brain, a computer's processing system does not have the inherent flexibility or adaptability to learn and evolve over time. Instead, computers rely on software updates and hardware upgrades to improve their performance and capabilities. Memory and storage in the human brain. The human brain's memory and storage systems are also fundamentally different from those of a computer. The brain's memory is distributed across various regions, with different types of memory, such as short-term, long-term, and procedural memory, stored in different areas of the brain. The process of storing and retrieving memories in the brain is a complex one, involving the strengthening and weakening of synaptic connections, as well as the formation of new neural pathways. This allows the brain to store and recall a vast amount of information, including memories, skills, and knowledge, throughout an individual's lifetime. Memory and storage in a computer's processing system. In contrast, a computer's memory and storage systems are more straightforward and centralized. Computers use various types of memory, such as RAM, random access memory, for short-term storage in hard drives, or solid-state drives, SSDs, for long-term storage. The computer's operating system and software manage the allocation and retrieval of data from these memory and storage devices. Unlike the brain's distributed and adaptive memory system, a computer's memory and storage are more rigid and structured. Data is stored in a specific format, and the computer must be able to precisely locate and retrieve it when needed. While computers can store and process vast amounts of data, they do not have the same ability as the human brain to continuously update and reorganize their internal representations of information. Adaptability and learning. One of the most striking differences between the human brain and a computer's processing system is their respective abilities to adapt and learn. The human brain is a remarkable example of adaptive and self-organizing systems. As mentioned earlier, the brain's plasticity allows it to continuously reorganize its neural connections in response to new experiences and information. This plasticity is what enables the brain to learn new skills, form new memories, and adapt to changing environments. Through a process known as neuroplasticity, the brain can create new neural pathways, strengthen existing ones, and even prune away connections that are no longer useful. This allows the brain to optimize its performance and adapt to the ever-changing demands of the world around it. In contrast, a computer's processing system is primarily designed to execute predetermined programs and algorithms, with little to no inherent ability to adapt or learn on its own. While computers can be programmed to learn through machine learning algorithms, this process is fundamentally different from the brain's ability to learn and adapt organically. Machine learning algorithms rely on large datasets and complex mathematical models to identify patterns and make predictions. However, these algorithms are still ultimately constrained by the limitations of their programming and the data they are trained on. They do not have the same level of flexibility and adaptability as the human brain, which can draw on a lifetime of experiences and continuously update its internal representations of the world. In conclusion, while the human brain and a computer's processing system share some superficial similarities, they are fundamentally different in their underlying structures, information processing mechanisms, memory and storage systems, and adaptability. The human brain is a remarkably complex and adaptive system, capable of continuously learning, evolving, and reorganizing itself in response to new experiences and environmental demands. In contrast, a computer's processing system is a more rigid and structured system, relying on predetermined programs and algorithms to perform its tasks. As technology continues to advance, and as we strive to create ever more sophisticated artificial intelligence systems, it is important to recognize the unique capabilities of the human brain and to draw inspiration from its adaptive and self-organizing principles. By understanding the differences between the human brain and a computer's processing system, we can better appreciate the remarkable complexity and versatility of the human mind, and work towards developing technologies that can more closely emulate its remarkable abilities.